Welcome to the MDCS.AI podcast from the Cisco Podcast Studio in Amsterdam. We're going to talk about simplicity regarding the AI infrastructure. And today we have two guests in the studio. It's Jara Osterfeld and Raymond Drielinger. Very good morning.
Good morning.
Good morning. I hope pronounce your names well.
Perfectly fine.
No complaints.
Good,
No
good.
complaints.
Good. And today we're going to discuss with you, where simplicity of cloud may break, the difficulties of an own AI stack or potential difficulties of an own AI stack, and what a well-designed AI stack can keep you away from many challenges. But first of all, to you, Jara, could you just introduce yourself to our audience and tell us who you are and
Of
what
course,
you do?
first of all, thank you for having me here. My name is Jara Osterfeld, as you said very correctly. I am an AI solutions engineer here at Cisco. I've been with Cisco now for 6.5 years, and I mostly consult our customers and partners in understanding how they make AI a success in their organization and what infrastructure considerations need to be taken into account to make this AI factory story a success and provide it securely to their users.
Securely. Interesting. We kind to tackle that for sure. And Raymond, can you introduce yourself?
Yes, thanks for the invitation, coming and sharing here the time together this morning. My name is Raymond Drielinger. I've got a background of 30 years plus in IT, mainly focused on data center solutions. And since 20 years, I'm running with a lot of enthusiastic colleagues, let's say MDCS, MDCS.AI, in which we typically focus nowadays, and let's say since the last couple of years, on customers in need of AI infrastructures, which they can run on-prem for many different reasons, and helping customers which started with an ease of use, let's say, experimental way, what can AI bring me as a company? So they started, let's say, low level, low entry, easy to go in cloud solutions. And what we see is that during the path and time frame that they start growing with their applications, they're going to run in challenges. So I think
that's a good bridge. That's a good bridge, Raymond, for, let's say, a kind of first statement, that cloud simplicity is seen as easy at the beginning of an AI journey, but complexity comes later. Why does the cloud feel so simple for users in the beginning of the AI journey?
Well, I think, and also if you talk to customers, that once AI was let's say coming on the table and people started talking about it, that they had something, okay, what can it bring to me? And then they had the discussion internally quite often, and it's quite often about the money, that they say, well, we don't know what it can bring us as a company, so let's start low level, simply reach out to a cloud provider and start experimenting with AI and what it can bring to a company. Nowadays, we see, since companies, and they had it up till a couple of years ago, that they had something, okay, our strategy is cloud first in many different topics, many different solutions. And that nowadays you see that, let's say, there are some challenges, unpredictable elements in there, which can be a cost thing. Let's say users being completely happy, having the freedom, let's say, in their own toolbox, in their sandbox, building models, doing all their application stuff. On the other side, CFOs within the company, they've got spiking bills month after month. It's not predictable. And I think nowadays also that you see companies which run mainly after they've done that training, they move into inferencing, that they've got something, okay, this is where we're going to bring our own IP in. And they start questioning themselves, okay, is this what we want to leave behind in a cloud environment? So there are many different topics that they say, and they reach out to us, well, can you help me? Not for all of it. We started in the cloud, but now we've got a couple of workloads which are seriously interesting for us to move them, let's say, to an on-prem situation where we as a company are completely in control.
Yeah. So, Jara, is that something you can see as well, that customers starting in a cloud, but the AI workload in production and more on scale is a kind of different situation, right? So do you see that at
yeah.
your customers?
I fully agree, and I think control is a very important key point, because if you want to bring those workloads into production to your users, if you run it in the cloud and especially consume a SaaS service of one way or another, controlling also which models are being used is not necessarily guaranteed. You can be degraded to a lower model than what you have subscribed for in the beginning, depending on the resources of the SaaS provider. But once you bring it on-prem, you are in full control over which models you're using, when you are upgrading to a newer model, which models fit your use cases best. So that's also one of the big discussions that we have with customers that's driving them back to on-premises.
And just a question for the both of you actually. So Raymond, you said, look, IT or cloud first policy, right? Or cloud only maybe.
Yeah.
So what is different from an AI workload compared to a traditional IT workload in that perspective?
Well, if I may answer on that question, is that if you take a look, and I quite often say to the customers in discussion we have with customers, is we call it traditional IT, where you have within, let's say, companies owning their own infrastructure. You've got the guys and girls from server management, we've got them from network management, we've got them from storage management, we've got them from security, different teams operating, let's say, in their own field of experience. Nowadays, what we see, let's say, in an AI infrastructure is that all these components, they're still in there. These are servers equipped with GPUs. We need network for communication, let's say, north, south, east, west. We need to have storage. We need to have security around, but it's going to be one tight solution, which is very tied together. And let's say, if one of the components is not performing in a proper way and giving the best possible communication, for example, then you see that other components, they start slowing down, which can result in GPUs being idle because the capacity is there, but different departments, they're doing their best from their perspective and focus on their, let's say, work field, that they do not communicate with the neighbors. So it needs to be a more holistic approach, let's say, in helicopter view about an AI factory, if we talk about in these terms, compared to traditional IT. That's what we see. And it looks complex, but I think once you're in that space and you gain experience with it, it's getting a normal thing. But it's a different way than, let's say, how we run IT in the last couple of years.
And if you say holistic view, Jara, could you articulate, let's say, the key layers in such an AI factory stack or AI stack?
Of course. So when we talk about the full stack, we start, of course, everybody, when we talk about AI, is talking about data. So storage is becoming a very, very important point. There's also laying the foundation for the application itself. We, of course, have, you mentioned GPUs, high performance computing. Many of these models, not all of them, are dependent on GPUs, which then need to be integrated across a network. Coming to the next layer of the stack, making sure that the entire system is being seen by the application as one, not by disaggregate GPUs and individual pieces, but the network that actually combines them and makes sure that, the system, as I said, sees the application as one, the other way around, that the application sees the system as one, the GPUs as one system. And on top of that, we of course have an orchestration layer. In AI workloads, we use Kubernetes, we use containerized applications because that's just the easiest way for us to scale based on demand, to have automated failure recovery. That is just a de facto standard in the industry. But how do I make sure that I can orchestrate that Kubernetes layer? That is another step. And then we move up the stack to integrate on the application layer. Which frameworks am I using? Which inferencing engines am I using to provide the model? And that is really how we see the infrastructure stack coming together. But to make sure that all of this actually works as we expect, we of course need to think about observability across the entire stack. And especially this is something that we are very focused on here at Cisco when we talk about the AI factory, is security. At every layer of the stack, we need to make sure that we can secure the data that's coming in, the data that is coming out, that we're not hurting our brand as such with the applications that we are delivering, and that we are making sure that regardless of where we are opening up our infrastructure, we can make sure that we do this securely and safe.
So given this layered approach, right, of an AI stack, when do you think, organizations in the cloud feels they have access, but no real control over their AI workloads or the AI infrastructure?
I think, one has to do with availability in the cloud. Do I have the GPU resources or computing resources that I need to have, and can I guarantee the network that I need to make sure that I can build and access the applications at a performance that I actually want to require?
As a customer, can you say to a cloud provider, I want to have this network or that network, or is it just the network that is provided, or do you know by any chance in the cloud what network you have?
Guarantees in that sense, I think, are very difficult to implement. I'm not sure if you want to add something.
No. That's the same we experience, and it's also what our customers are experiencing. And well, there's network connectivity, because otherwise components and data cannot transfer and flow, let's say, through the whole stack. But there's no brand on it. That it is there, it's communicating with each other, and let's say questions we've also seen, and let's say proof of concept we've run with customers, let's say running their workloads, which can be training or can be inferencing in a cloud environment versus an on-prem environment where you've got your full control and where you've got, let's say, you can tweak your whole environment, that the same workload on the same GPU and network infrastructure on an on-prem is running much smoother, much faster, delivering much earlier output compared to a cloud environment where you quite often are in a shared environment and you can be hurdled by, let's call it, a noisy neighbor.
So what you're saying actually, Raymond, is that a cloud environment where you share resources can have impact on your performance and costs actually.
Yeah, actually yes, because quite often you see, let's say, if you spin up your instances, let's say they start charging, but when I'm, let's say, claiming a GPU, a set of GPUs, but the performance is lower, that, for example, the data is fed to the GPUs to be crunched, it means that the time I'm allocating the GPUs will be longer, and by the end of the day, it will generate a bill which is higher due to wait times.
So when we say, look, so the cloud is probably a good alternative when organizations start with AI, because you can spin off your GPUs and other tools and create your environment. But what is the moment organizations realize that the cloud may not be the best future for them and should consider an own AI environment?
I think yesterday I had a nice discussion with one of our customers, and it's about data sensitivity. It's a company which is running their own on-prem AI factory, but for, let's say, development purposes, they have access to cloud environments where they start playing with their applications, quickly grabbing frameworks together and see, okay, what can it be? How can I tweak it? And especially which kind of GPU performs best under a certain workload. Once they've got that work done, and it's all development, they pull it into their own environment, and from there they've got the full control, the data, the IP, they feed into the environment, and then they start putting it in production or let it be on an inferencing mode.
Yeah, interesting. So
it's a mix.
There's a flipping point at the moment. Good. And when you talk about your own AI environment, so what are the common pitfalls, or what mistakes, sounds a bit negative, but challenges are customers facing when designing their own infrastructure? Could you, based on experience, Jara, give some examples of
Of
those
course.
cases?
I think one thing that also relates back to what you just said around the cloud environment, I think experimentation is a very important part of making sure that your AI journey is going to be successful, so that you understand what you need and how you can implement it best and what your requirements are. But I think once you understand what your pilot should look like, you need to be very aware of what scalability you're going to run into, how you're going to secure the application, and how you make sure that the environment that you build this prototype into is actually going to be reflective of what you will have in production. Because if you do your experimentation in the cloud with variables that you don't control, and then you bring it into production where you do have these controls, where you can tweak it further, I think that is one very important point in that sense.
And what's your view on when scaling AI? Does it impact the complexity of an AI environment in general?
I think what you see once you have a prototype is a very condensed environment, right? Very protected. You get resources assigned, regardless now where they are, and you develop the prototype. Once you unleash it into production, many times you have an idea of the users that will use it, but the more users you're introducing to this application, the more flexibly you need to scale. Maybe you want to introduce something like on-demand scaling, where the infrastructure is now not only hosting your application, but also those of others. And where you want to minimize the time your GPUs run idle. So you have all these implications that now become a very determining factor to be as efficient in the way you use that system. Qua scalability, it depends on how your users interfere with it, or how many users are using it, how many edge cases you have. And the moment you open your infrastructure up to real world users, this is something you need to account for. And this is where you need a platform that can actually allows you to scale in the way your applications and your AI workloads demand it.
Yeah. And do you have any thoughts on the, let's say, the do's and the don'ts of when you say, look, an own environment is strategic-wise better for us, but what are the do's and the don'ts in the considerations about that?
I think we always say, or the entire industry is talking about an AI factory. And when I hear the words AI factory, I think about a gigafactory. I think about a huge environment, but that is not necessarily always the case. You can start very small and you can scale as your business requires it. What I would recommend companies to do is very much thinking about what they expect this environment to grow into and build a strong foundation that will provide them the capabilities to grow, and that provides them with a strong basis and a strong baseline to bring the first use case to life. Because what we see organizations do is a use case first approach. They think about one of the use cases that will deliver the biggest ROI with the lowest TCO. And I would recommend making sure that the platform that they're going to land this on, to have a strong foundation, to have thought about the different integrations, to have thought about security from the bottom up, to then make sure that this can easily land on this platform and that it can scale either based on user demand
or a strong foundation.
Exactly.
Yeah. Yes. And then if you're considering a strong foundation, there might be two choices you can take there, right? So, okay, you decided to go on yourself. You want to have your own infrastructure because of the reasons we just mentioned. And they have two choices, right? You can either do it yourself, so you can buy all kind of components and put it together into one framework, one infrastructure to use, or you can use the reference architecture from Cisco, for example, that gives you some guarantees on performance, I would say. Can you explore a bit on those two choices?
Yeah, of course. So the complexity of the system does not lay in the individual components. I think we've seen with the rapid developments also of what NVIDIA has been doing, how AMD is following up with the GPUs. I think we see that the individual components are really good at what they are doing already today. Sure, we are developing them further and further, but the complexity doesn't lay in the individual components. Where it does get complex, as we walk through the stack that I was walking through before, is the integrations in between. Where is a handover? Where do we do scheduling? Where do we do the processing and the inferencing? Where do we do scaling? All these integrations of the different components need to be thought of and need to be thought about. And these are often different vendors that come together, different vendors that form the entire stack. And this is really where the complexities are and originate.
And Raymond, this is not only a matter of hardware, right? It's also a kind of software layers in between the different components that makes it complex.
Yeah, that's exactly. And let's say referring and going further, what just has been said is that going back to the question you raised, okay, where is it getting complex, or where are companies being challenged if they glue together their own AI solution? Like I said before, you've got, let's say, the different departments, let's say servers, storage, networking, security, and they all do their best to put the new components in there. But let's say AI is having the need for, let's say, different components. Yes, we need networking. Yes, we need storage, but we need high-speed networking. We need high-speed storage, which also brings a cost component. Quite often there you already see that trade-offs are made. Well, internally here we ran on 10 gig, which is extreme. Well, with 10 gig within an AI factory, if it's a huge one or let's say a small one, it's not enough. We speak about 100, 200, 400 gigs. And they start looking at it, okay, but I was used to work with network provider type A and storage provider type B. Well, if you glue them all together, in basic, you've got all the components, but then let's say the fine tuning starts. And I think by the end of the day, if we go back, like already stated, let's say building a reference architecture not only means, okay, we have done it before, we build it up from scratch, we make it a scalable environment depending on the needs and let's say the near or longer term future from a customer. And we put components in place which has been tested, but also more than important, if you take a reference architecture, it is, let's say, with a predefined outcome. If you deliver these kind of infrastructures to a customer, let's say to make step over to a racing team, a Formula One team, if you start racing, you know your car will drive 321 kilometers an hour. If he's not driving 321, we go back together, let's say with all the guys and girls and teams, and we work on that car until it's having that speed which is promised. And also during maintenance phases, you've got one point where you can go, and it doesn't matter if you upgrade your storage or your networking components, server components, or you tweak in security. By the end of the day, the team should be ready again for the next race. So that's where you also gain your support in there.
So,
I think.
oh, sorry.
Sorry, if I can add to that, because how we see the secure AI factory that we brought to market in collaboration with NVIDIA, what we like to say about that stack is that it is loosely coupled in the sense that you can scale different components separately, but it's tightly integrated. So whatever choice and vendors you do of the different components, there will always be a tight integration when you bring it to market.
Also from a support point of view. So
Indeed.
if an organization is facing whatever challenge or want to discuss certain elements of such a stack, they have one number to dial. Is that what it is?
Indeed, this is how it, and maybe I can go into a bit more detail into what our stack or the secure AI factory that we brought with to market with NVIDIA actually looks like. So at the core, we of course have our Cisco UCS high performance computing infrastructure together with our Cisco networking Nexus networking. But around that, and this is really how Cisco has always been going to market in the data center space, we work with partners. We work with storage vendors. That can be a NetApp, a Pure, a Vast as a partner that we work closely together with. It can be Nutanix, with whom we have a long-standing relationship. So customers have a choice in either integrating existing systems that they have, or redefining their storage strategy. And if we go up the stack, on the Kubernetes layer, if we now skip the computing and the networking layer, which is of course Cisco, we can work with an OpenShift, who we have a very strong relationship with Red Hat. It can be vanilla Kubernetes, so there are choices there, just as much as with the GPU choices and the choices that NVIDIA also brings with their AI enterprise software suite. And of course, I keep saying security. It's such a big and pivotal point for our proposition, given that Cisco's focus has been many years now on security. This is something that we can integrate in the entire stack, from the application down to the networking layer, where we, for example, now also have brought smart switches to market, where we can infuse DPUs into the switch and enforce policies in the fabric itself, which is something very unique to us as Cisco, of course, being a networking vendor.
And to give, let's say, low to simplicity, right? It's here on the boards. We have two beautiful, let's say, things on the table. Besides the cookies, it's a ready to go race car, and some bags with all kind of components. Is that also, let's say, a kind of storyline between do-it-yourself or buying a reference architecture?
100%? Or
For me, also 100%. Let's say, if I take a look at, let's say, at a race car versus, let's say, a bag of components, you mentioned the number, it's 200 plus components, and you need to build it yourself. A race car, Formula One car, is for us reference architecture, which we glue together, which has been tested, validated, and also supported. Let's say, quite often, you've got a copy of a reference architecture internal at the vendor so that they can quickly troubleshoot and support it. Let's say, take a look at configurations instead of, and reverting back again from where started for, let's say, companies who start buying their own components because they want to build their own AI factory. It's something which is there. And let's say within the bags, there are all the components which are needed, but how to glue them together and how to maintain them to keep winning races week after week.
indeed, it's very much an opinionated stack that is set into the market and that customers can consume with their operating model and the way they need it, while it reduces time to market because it is this opinionated stack that's been tested, that's been validated, and that customers can consume in that manner. And coming back to what you said in your previous question to support, all these partners that I mentioned that we work together with, if anything is going wrong, you can call Cisco and we will in the backend make sure that wherever the issue is, whether that is with Cisco or whether that's, let's say, that's within Red Hat OpenShift or in the storage layer, we in the background will take care of that. So there's one point of contact, and for the customer that really resolves the issue of finger pointing of different vendors saying, check with your compute vendor, check with the GPUs, check with the storage layer. But this will be taken care of by us
So
as a firm.
I think an important takeaway then for our audience is that an own AI stack can be simple, but stick to reference architecture where you know upfront what's going on, because as you said, Jara, the complexity is not so much in the individual components, but gluing them together because you have many of them and many at high speed and fairly delicate for keeping the performance up to speed.
Yeah, and give that opinionated stack also to your developers, because if they're starting developing applications and AI applications that are very dependent on a very specific set of technologies, it becomes very difficult to scale that as you add more workloads on the infrastructure and as you scale this infrastructure.
Yeah. And Raymond, before we spoke about another performance killer of AI, and it's fragmentation, which you said, I see a lot fragmented environments at corporate levels,
corporate
hospitals,
levels, let's say
government
governmental office, but also let's say within enterprise businesses that you see there's not one strategy which is top down or how you want to mention it. So we always call it island AI. You've got your own departments running on their own and small environments which fit within their budgets, and let's say it's scattered. And another quite important thing we see nowadays, and this is also where we have discussions with our customers, is that there's data sovereignty. There is a geopolitical situation going on right now that companies, they want to know, okay, which kind of data do I bring in, which kind of environments, and what stays behind, because that's quite often what a user is not aware of. And we see companies who said, okay, we make a policy which is very tight, but which is creating, let's say, for the smart guys and girls working on these models, building these models, creating a situation where they cannot operate and use their imagination and go beyond boundaries. And what you see over there also is that they move away and call it again a sort of shadow IT in an environment where they've got the freedom and they've got something, okay, this is where I can operate my environment. So I think, again, if you keep it internally, you can more guard them and let's say give them functionality where they can do and make it all happen instead of guardrailing them.
Yeah. So one hybrid, let's say AI facility rather than all kind of fragmented initiatives.
Yes.
Also in terms of security, I think.
In terms of security, yeah.
And compliance, really.
And compliance, more than important.
That makes sense. Another remark on owning a stack in terms of simplicity is that could organizations be afraid of stating what I'm buying now is probably out of date in 2 or 3 years time, so I'm afraid of all kind of old hardware. I don't want to have that hassle. But there's a solution for that, right? It's called lifecycle management. So is that something organization can also consider when thinking about an own environment, to put it in a kind of lifecycle management structure?
Yeah, we've got our customers, let's say, on purpose choosing for, let's say, something non-traditional, going into a lifecycle management solution, in which they said, well, our vision, for example, is that we need to attract top talent. And if you want to attract top talent, it means you need to offer them the newest, at that moment in time, available solutions to do their work with, because otherwise they go to your opponents. And what gives them part of or sort of flexibility also is that you can determine, okay, I go into a lifecycle management solution in which I determine upfront, okay, I will stay in here. And for example, if you take a look at the life cycle of GPUs, it's 1.5, 2 year, something new will come up. Yeah, we go from H100, H200, we go to the Blackwells, B200, B300s, and you can fit it and tune it in there. And by the end, let's say when a new generation is popping up, as a customer, you've got a choice. Do I want to continue because this GPU environment, this AI factory fits me more than well? You can extend, let's say, your lifecycle management. You can also determine, okay, what's coming up now? And that's quite often where we can help customers to do calculations. Okay, we go into a new type of GPU, which gives a higher performance, and we can calculate together with the customer what it will bring. Let's say, extremely, instead of 16 GPU servers, you can scale down to 8 new GPU servers, which will bring you profits in power consumption, which will bring you profits in, let's say, speed you can get out of the environment. And by the end of the day, let's say, it gives them more flexibility. But definitely, if you compare it and if you discuss these kind of things, let's say, with purchasing departments within companies, they've got normally, let's say, they're used to go for, let's say, a server or storage refresh cycle of 5 up till 7 years. In a GPU AI world, it's, let's say, reversed. Try to run as fast as possible, but also be realistic. Do I need it? Ask yourself the question, do I need this kind of performance? Or can you divide and start playing, let's say, the fastest GPUs now available in the market for training purposes? The sooner I've got my results. But when you start running inferencing, it can be on a lower type of GPUs. So you start mixing and matching.
So it's diversity of your GPU
Yes.
park, actually.
Exactly,
Yeah.
exactly.
Interesting. Okay, so can we conclude that cloud can be perceived as simple in the beginning of your AI journey? You will enter a flipping point where considering an own AI stack makes sense. But when you do that, keeping close to a reference architecture with an LCM, so lifecycle management construction, is probably the safest way for companies to be secure about performance, sovereignty, security, etc.
Yeah.
Good. So, is there a tip you would like to give our listeners when considering AI infrastructure in general, with around simplicity as a kind of closing note?
I think for me, it comes down to 2 things really. And one is about security. This is an integral part, and this needs to be one of the first things that we think about when we think about AI, regardless of where we host it. And 2 is what I mentioned before. Think about your initial starting point. Start small, but build this platform out in a way that you can scale with. Think about the starting point properly. Have an idea or think about where you want to grow this to.
Future-proof, so to say.
Exactly. And think about the scalability of the system so that you can get the most out of it, really.
Exactly, exactly. I completely agree with your, let's say, ID. And the other thing I would like to say, let's say, as an advice also is that if the ideas are there that you are working with AI workloads, and you've got something, okay, and now what should be my next step? Simply reach out, and it's not, and by the end of the day, of course, you need an infrastructure. If it's a cloud infrastructure or if it's an on-prem infrastructure, components can differentiate in there. But by the end of the day, how we approach it is that we start looking at security, especially together with Cisco, but also from an application workload point of view, and revert back, okay, and what is the impact from this workload, which is now, let's say, in a test environment, which will scale up, which kind of infrastructure is needed underneath, let's say, which gives me the flexibility to grow at scale, which can be in the beginning that you take a look at the specifications, say, okay, this amount of networking, this amount of storage, but let's say the components are there, and yes, you need to do and place it finally, let's say, and do the investment, but once it's in there, it's plug as you go, and quite often it's just attaching GPU servers on an existing infrastructure which is completely built up from scratch, which has the security in there, which is having the performance in there, and then you can go.
And take out the guesswork of the integrations between the different components by following something like an enterprise reference architecture from NVIDIA, or what we call Cisco validated designs, the combination of both. Yep. That's really, I think, what matters.
That's key, eh? Otherwise you're ending up with 4 different backs of door, 4 or 5 different vendors with a lot of components.
Yeah, definitely. And what I see over here, there's also a sort of instruction how to glue these parts together to build a racing car. But quite often, let's say, there's not even instruction. You get a box of containers and see how you glue it together. Yeah. And once it's glued together, let's say all the hard parts is always something I say which you can touch. There's also configuration in there. How do I need to set it up? How can they, let's say, communicate in an optimized way?
Excellent. I want to thank you both for
pleasure.
Thank
your
you for having us.
insightful thoughts. Thank you for listening to this MDCS.AI podcast recorded in the Cisco podcast studio in Amsterdam. And if you want to keep up to date about decisions and considerations around AI infrastructure, please subscribe to our channel, and we keep you up to date with a lot of insightful conversations around this topic. Thank you.